Hello, 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 hello. How is everyone doing? Welcome. It is Wednesday, September 25th, 2024, and we are live. Going to work on projects as per usual, continue working inside of processing or trying to learn processing from the ground up. And today we're learning about random numbers, as per the name of today's stream. And yeah, I didn't get to stream yesterday, unfortunately, because of some life stuff, out of stream stuff going on, but I'm back today and that's what counts. So yeah, here, let me go into my display cam here. Oh, that's not display cam. There we go. Here, let me load up my board to start us off the stream. Here, let me copy and paste this board into today. Pretty small board from last time, but that's okay. So 22nd, so today's 23rd stream board 9/25-24, right? Yeah, that's correct. I'll paste it in. Cool. And here, the song's a little too calm. I also skipped one during the starting soon screen, if you caught that too. But yeah, here, let me take a moment to make sure I'm live on Instagram, just because I have to set that up properly. Add a message that I'm live over on Twitch and YouTube. Which unfortunately still shows up without my name, but that's okay, you know. Hopefully Ecamm Live, this software I use to stream, fixes that soon. I'm also gonna make sure that the YouTube stream is up and running, and it is. Cool. Cool, so yeah, let's jump into it. So let's recap what we did last stream. So we completed incrementation operations chapter and learned processing, and that was it. You know, it was a short stream, but it was good. Learned a lot of things by doing that. And today, what are we doing today? So our agenda for today is to review what we did last time. Quick, simple, easy. Not as much as usual, but that's actually kind of a nice change of pace. And then we're going to jump into the random numbers chapter, and then we'll make an agenda for tomorrow at the end of stream. So yeah, no assignments today, no projects. We are just working through tutorials, but hey, that's kind of refreshing, kind of nice. So yeah, here, let me paste in the agenda for today. Say for today's stream, September 25th. And yeah, here's our notes from last time too on incrementation operations. Just to recap it real quick. We wrote different shorthands for writing incrementation operations. So for example, circle x equals circle x plus 5 can be rewritten as just circle x equals plus 5. And also incrementation operations of 1, where the code is increasing by 1 over and over again, is so commonly written that you can just write circle x, the circle x being the variable. So variable plus plus, and that's actually how C++ got its name, which we learned last time, which I thought was pretty interesting. And yeah, shorthand operations also work with multiply, divide, and subtract. So we learned that as well. And again, the shorthands, the incrementation operations can all work with those. What's the word for them? You can just work with multiply, divide, subtract. That's all I'll say. And you can simplify your names for variables. So you can simplify our variables. Simply name our variables x, for example. We really can name our variables whatever we want, whatever makes the most sense for us. I kind of like the idea of it just being like x equals that. I feel like that might be the most simple and straightforward for me when I work on projects, but who knows. But anyways, we are actually, I was gonna delete it, but here, let me just unbolt that. Delete this, because we're starting a new stream board, and that was saved from last time. Who is here? It is Joe. I knew it was Joe because you said sturdy. I can't stay, but love you, bud. Talk soon. Have a be sturdy stream, Dad. Joe, thank you so much for stopping by as always. Love you, dude. thank you so much for stopping by. For real. So good to see you here. Glad you're sturdy. Hope to catch you at your stream sometime soon. Yeah, thanks for stopping by. But yeah, so what's the name of today's chapter? I think just random numbers, if that's right. Let's see, going back to Twitch on my side screen. Actually, let me set up Twitch and Instagram so they're side by side because I'm having that issue with reading chat on Instagram. Hopefully this way I can see everything a little bit more clearly. Actually, this looks more chaotic than it did before, but that's okay. I'll try it for now. I'll rearrange it in the future. But yeah, notes from random numbers. So here, let me load up the tutorial. So that is here. I'll also say too, I finally finished that book by Adam Savage, Every Tool's a Hammer, and it was really, really good. I won't talk about it again because I already talked about it on stream, but yeah, cannot recommend it enough if you're into making things. So we are gonna go to, oh, we're just on the page itself. That's right, I just had to scroll down. I had to
Learning
remember
processing.
for a second. And then we go to random numbers. So let's see. Here we go. Yep, it is just called random numbers. So I'll start like right here. Yep, perfect. Perfect spot.
All right. I don't know what you've made so far watching this video, although I certainly would love to know. So check the video description for how you can share stuff with me. But I don't know about you. I'm feeling
When we make something that I'm really excited about, I'll probably end up doing that here. Actually, let me write that down in the notes.
check the video description.
Codingtrain.com/submit. Here, let me write that down. Put the music back on. Submit our assignment examples to the codingtrain.com/submit. Oh, cool. And it links it right here. Does that link work? It does. Sorry, it opened up on my side screen. This is what it looks like here. Cool. So I'll say, actually let me start a new link. I'll say, copy and paste this, can it submit our example assignments? Nope, I already have a text block going. And I'll just say here. No need for it to be bulleted. Delete the line before. There we go. Perfect. There we go. Cool. Sorry that took me a second, but I thought it'd be good for me to set up. And yeah, anyways, here, let's get back into the tutorial. I also forgot to put a link to it in the chat, so I'll do that now. Cool, and let's get into it.
How you can share stuff with me. But I don't know about you. I'm feeling a little bit like sad. Like all I've got is this circle. Yeah, it's moving. I mean, this is a huge accomplishment, but there's not a lot of possibilities here. Don't worry, I haven't forgotten about figuring out what to do when that circle reaches the edge and have it move back, bounce off of the edge, if you will. But before we get there, I've got something really exciting to show you.
I forgot that was the initial goal, is to have it bounce around the screen. I feel like he's talked about that before.
Going to just explode the possibilities of what you can create right now in processing. And that is the random function. Up until now, we've looked at two different kinds of lines of code that you can write. One, a command, or more precisely, a function call. This is anything like background. It's got the name of the command followed by parentheses and some number of
I think
arguments.
I'm gonna do what I did last time, which is watch the video, then take notes. Wait, actually, how long is this chapter? That might take too long. It's 2:02. It's about between 8 to 10 minutes long. Yeah, we'll go with this for now, and then I'll probably go back and add notes in just a moment.
And a semicolon. Line, stroke, ellipse, circle, all of these are the same. We've also now seen, with variables, assignment operations. Here are some examples. We're setting circle x equal to 100,
Didn't know those were called assignment operations.
or set circle x equal to the
Because, oh, I guess that's an assignment operation, and this is an incrementation operation because it's increasing. But I wonder if they're both assignment operations. I guess they are.
result of some type of mathematical expression. There is a way to do both of these in one line of code with certain kinds of function calls. At the moment, every single function call that I've shown you just performs an action. Set the background color, set the fill color, draw a circle, draw a square. But some functions actually answer a question. And I think the most wonderful function that we could begin to demonstrate this concept is the function random. The function random in processing ends with a resulting value. It doesn't just perform an action. The action it performs is it picks a random number out of a hat, but it gives you that value back. The function itself evaluates to a random number, meaning we can take the result of the random function and assign it to a variable. Circle x equals random. Now, random also
Interesting. Yeah. I'll have to definitely go back, watch this a second time in just a moment.
require arguments. If we want a random number, we need to specify the minimum value and the maximum value. What is the range of numbers we want? So for example, if I wanted a random x position anywhere in the window, I might say the minimum value is 0 and the maximum value is 640. So now I am both performing an assignment operation, I'm giving a new value to circle x, but I'm also getting that value not from a hard-coded number or a mathematical expression, but rather from the result of a function. The technical term for this is that this function returns a value.
Before I write the notes, I think I want to see him type an example of this. I feel like that'll help me wrap my brain about it, and then I'll be able to write the notes more clearly if I see that example, if that makes sense.
In fact, it returns a floating point number. The first thing that we might do with random and a sketch like this is, well, every time it runs, it does the exact same thing. But if I added something random, like give me a random x position, now every time I run the sketch, there it was kind of in the middle, there it's all the way to the left, run it again, oh, now it's more toward the right. But let's make a little bit more dynamic version of this.
Exactly what I was talking about. I feel like I'm starting to understand, but I'm curious to see it here.
So I've got a sketch right here that draws a single rectangle in the middle of the canvas. I have two variables, one for the size of the square and one for the width of the outline of the square. I'm calling it square size and line width. Those are my variable names. How am I doing variable name-wise? Pretty good, I think. So if I were to change square size to some random value between 50 and 150, and line width to some random value between, say, 4 and 16, now every time I run the sketch, I get a different size square and a different thickness for the outline. Demonstrating this by...
Interesting. That's cool to see it in the context of the variable being defined. That's the word I was looking for.
Running the sketch over and over again is kind of awkward. So a nice trick I can do is in mouse pressed, I can put these lines of code in there. There's something that I've done that's really wrong though. Remember in our 3 steps about a variable? Declare a variable, initialize it, use the variable. Well, this is me declaring it. This is me initializing it. Here I'm using it. I do not want to redeclare it. Instead,
Yeah, I was confused about that for a second.
I just want to use it. So I want to set the value of square size and line weight to something new. Run the sketch. So something I forgot, also interestingly enough, is
I'm so confused what happened.
background is in setup. Put background in draw. And now here's what,
I see. Or I think I see.
every time I click the mouse, I get a different square. This might seem kind of basic, but if you had designed an entire house, you could actually vary the house
Oh, this is cool.
randomly every time, maybe the size
Trying to think of a fun project idea where I can utilize this. It's very cool.
of the building, the number of windows, where the door is positioned. These are things that you could do by having more variables and more calls to random. And I don't have to limit myself to picking the random numbers when I initialize the variable or in mouse pressed. I can actually take these lines of code and put them right inside of draw. It's a little jarring how much it's flickering, but what if I add some nice alpha to both the stroke and the fill?
Well, it happens.
Why am
I
I
thought it
not
would just be transparent.
seeing anything? I have the background in draw. For this effect, where I'm trying
What?
to demonstrate the blending of all these random shapes, I need to draw the background just once in setup. Just with adding some randomness, we've got
Oh, interesting.
a more
I
dynamic
think I understand what that happens.
pattern and shape. Let's look at another example.
I love the effect it produces for the animation too. That's very cool.
Here's an example that just draws one circle in the center of the window. First, another shortcut. If I have multiple variables I want to declare that are of the same data type, I don't have to say float x, float y. I can actually say float x, comma y. And here I divided x and y and RGB up separately because one's for the position, one's for the color, but I could actually put these all in one line of code. So now I have 5 variables all declared at once. And then in draw,
I didn't realize you can declare multiple variables in the same line of code. Has he talked about that yet? I don't think so.
giving all of those variables a hard-coded number. So we have a white circle in one spot. But what if I were to allow each of those to be random? Look at that. Every time through draw, a new circle is drawn at a random location with a random RGB value. Maybe I want to constrain the range of color a bit more.
I'm still confused about how the frame rate works for that. Like, why were they starting at different points? Or they weren't all like in unison with each frame of video. Yeah, I'm not quite sure how the animation is working in that regard, if that makes sense.
At a minimum, the blue value will always be 150 and the red value will always be 100. And maybe the green value is always going to be very little, just between 0 and 50. Varying degrees of pinkish purple. I like that. Ooh, what if I add some alpha? Over time, the shapes are blending. It's a nice pointillist effect. Something else to mention is that while I said that the random function takes 2 arguments, a minimum and a maximum, if your minimum value is 0, you can actually give random just 1 argument. So this can actually be written as random just 640, and it will assume some random number between 0 and 640.
Another example of a shorthand that I'm not sure if it would confuse me more as if I'm using it as I started out, or if it would be helpful just to kind of practice the shorthand.
Back to the code, I can remove that, this, and this here, and there we go. And while we're at it, I should probably use the built-in variables width and height so that if I resize the sketch, it will always still spread the dots out all over it. So let's say x equals random width and y equals random height. Okay, hopefully you have so many ideas percolating in your head, you just can't wait to add random all over your code. Maybe you're gonna make your own pointillist design like this, try other shapes besides just dots.
I do feel like this chapter, another reason why I want to go through it a second time to take notes is I feel like it's such an important chapter in the grand scheme of things too, in terms of, and again, I mentioned this last stream because, the first chapter of this book that he wrote, The Nature of Code, is all about randomness too, and I feel like it is really important to, just because it's the same topic, I wonder if that's will be helpful for us. Like, I already see the same random function that we're learning about right now. But anyways, sorry, y'all can see what I was looking at, even though there's an online version of the book, so if we do look at that, we'll look at that very briefly at the end of the stream. Might be a little bit too much of a tangent, but who knows? Maybe it'll be nice.
You put random lines all over the sketch. Ooh, that's a nice idea. Could you make a random design like...
He's about to give us another assignment too, so I don't think I'll have time to work on that today. Maybe I will actually, but I might end up saving that for next time just because I don't know if I feel up to working on an assignment like that today, but we'll see.
Example of a new random house every time you run the sketch. You could also go back and explore that painting program, the one where the dot smeared around based on moving the mouse. What if every time you click the mouse, you started painting with a new color? Or maybe there's some other way you could use random in combination with the size of the dot or the color that I can't even think of right now. So go and explore the random function, see what types of designs you can make, take a break for yourself, and then when we come back, oh, it's gonna be time. We're gonna get that ball. That ball is gonna hit the edge. It's gonna bounce. It's gonna turn. It's gonna be a thrilling moment. I'll see you then.
Cool, so I think this is the next big chapter. I think he put like the main chapters, the headers with stars, and then each other point is kind of like a sub-chapter. So yes, yeah, we're currently in the variables section, which makes sense. So next we have conditionals. I feel like this will also be really important for coding in general. Then we have loops, arrays, what else? Functions, which I thought we already talked about, but maybe something else. Classes and objects. This is a big section here, wow. Oh yeah, and this is object-oriented programming, I assume. I assume this is related to that. Because that's something we have to get in, not have to get into, but something I'm just going to learn for working inside of Godot. Conductor, construct arguments, that's a subchapter. Confetti project, so I guess that's the last project, I assume. Maybe something that encompasses everything that we learned in the entire course. But yeah, we're approaching the halfway mark. Let's see, so we're about to start conditionals. And then out here, the bouncing ball before Boolean variables is about the halfway point. Boolean variables, I've heard the word Boolean before with coding, but I'm not quite sure what it means, so it'll be interesting to finally learn what that means. Conditionals, how long is this? I might try to get through that today too. Yeah, it's like not even a minute. Let's just see what the intro is like. Oh, but we also have to do the assignment. Maybe I actually shouldn't do that. You know what? I'll watch it. I probably won't take notes. Then we can save that for next time, but I'll go back and take notes on random numbers before the end of this stream just to help myself kind of like properly digest the info.
Welcome back. I had a break for a few days, wearing different clothes. I am just full of energy, raring to go because, even though I say this a lot, this section might be the most important part of everything you might ever learn to do as it relates to coding. You haven't really been able to do very much. You can make drawings, you can add some color, you can animate things, but without the ability for a program to make decisions and take different paths based on conditions that are happening within the program itself, there's very little you can do.
What they just knocked into? That was kind of funny.
It is called a conditional statement. The grand finale of this section will finally answer the question, how do we tell this circle that when it leaves the screen, it goes past the edge of the canvas? How do we tell it to turn around and move in the other direction? This cannot be done without a conditional statement. You might recall, back when I was talking about setup and draw, I said, oh, this thing about a block of code with an open curly bracket and a closed curly bracket, that's going to be very important.
Interesting. Cool. So yeah, we'll save that for next time. Here, let me set up the screen in a way that's better for taking notes here. Apologies if you're watching on Instagram, it's most likely getting cut off for you. About as big as the video gets, I'll move it towards the center here. Cool. I think this should work. Yeah.
A conditional statement
keeps playing songs today that are too relaxed, so keep having to skip those. I'm not having to, but I've been skipping those here. Let me go back to the beginning of this chapter. It's easier if I make it full screen for that. Then right here. Cool.
All right. I don't know what you've made so far watching this video, although I certainly would love to know. So check the video description for how you can share stuff with me. But I don't know about you, I'm feeling a little bit like sad. Like all I've got is this circle. Yeah, it's moving. I mean, this is a huge accomplishment, but there's not a lot of possibilities here. Don't worry, I haven't forgotten about figuring out what to do when that circle reaches the edge and have it move back, bounce off of the edge, if you will. But before we get there, I've got something really exciting to show you, which is going to just explode the possibilities of what you can create right now in processing. And that is the random function. Up until now, we've looked at two different kinds of lines of code that you can write. One, a command, or more precisely, a function. Different kinds.
Yeah, go back. So far, we've learned about two ways to write a line of code. I like how he said line of code instead of like I know he's about to say function and other stuff, but I didn't really think about it as most of the lines of code so far have been written in these two ways.
Lines of code that you can write. One, a command, or more precisely, a function call.
So first, command, or more precisely a function call. I know it's bad note taking to just write what the teacher or the lecturer or whatever, whoever is the YouTuber in this case, also a teacher then. Whatever the teacher is saying. But, you know, I feel like he's doing a great job of kind of summarizing and condensing everything. And when I go back to these notes, I want to be able to kind of read them like a book too and skim around to certain areas. So, yeah, I think it's helpful in some areas for me to write what he's saying and then to leave out things that he's already talked about or aren't summaries or whatever it might be, or simplify them as proper note-taking should be. But
this is anything like background. It's got
I'm not gonna
the name of the command.
For example, background, because that I think I remember pretty well. Actually, should I write it down? Yeah, you know, I take it back. Because I'm thinking if I go back to this, I might not remember to go all the way back to the beginning. So I'll say, for example, comma, background. We'll write down his exact example, 255, 130, parentheses, semicolon.
Followed by parentheses and some number of arguments and a semicolon. Line, stroke, ellipse, circle, all of these are the same. We've also now seen, with variables, assignment operations.
Here, I'll make these bullet points underneath. So I'll say second, assignment operations. For example, because I know he's about to give an example.
Some examples.
Say, for example, circle x equals 100, or circle, it's colon so semicolon, or circle x equals circle x plus 2 semicolon. I'm still confused about if they're, so I know this is an incrementation operation, but is that also an assignment operation? I guess it is, because it's still assigning a value to the variable. So yeah, I guess they're both assignment operations. I guess it's like rectangles to squares. Incrementation operations are assignment operations, but assignment operations are not incrementation operations, because this is an incrementation operation and an assignment operation, but this is only a assignment operation because there's no incrementation happening in the code.
We're setting circle x equal to 100, or set circle x equal to the result of some type of mathematical expression. There is a way to do both of these in one line of code with certain kinds of function calls.
I'll say there is a way to combine these two into one line of code with certain kinds of function calls. Here, let me make sure that this bullet point is underneath this one. There we go. Oh, that's weird that this one... Weird that this one didn't put space here or a tab. Can I fake it? No, I can't. Weird. Yeah, why is it... Oh, Freeform is such a weird software for note taking. It still has quirks like this, but I'll just leave it the way it is. It's distracting and annoying, but hey, it'll take too long to fix it. I don't even know if we can.
Every single function call that I've shown you just performs an action. Set the background color, set the fill color, draw a circle, draw a square. But some functions actually answer a question. And I think the most wonderful function that begin to
I'll say most functions ask questions, as we've learned so far. But some functions answer questions.
This concept is the function random. The function random in processing ends with a resulting value. It doesn't just perform an action. The action it performs is it picks a random number out of a hat, but it gives you that value back. The function itself evaluates to a random number. We can take the
Well, this is a hard thing to condense into notes and trying to think.
result of the random function and assign it to a variable. Circle x equals random. Now, random also does require arguments. If we want a random number, we need to specify the minimum value and the maximum value. What is the range of numbers we want? So for example, if I wanted a random x position.
I think this is the part in the tutorial where, I had a long, kind of stressful day. I think this is the time where I need to kind of revisit this tomorrow to be able to really digest it properly. Because I understand what he's saying, but I feel like because I'm having trouble putting it into words in my notes, that's when I have to kind of sleep on it, let myself come back to it tomorrow, and then I should be able to write it a lot better, because as I've learned in previous streams, that has been extremely, extremely helpful so far. Here, I'm gonna move this up.
Anywhere in the window, I might say the minimum value is 0 and the maximum value is 640. So now I am both performing an assignment operation, I'm giving a new value to circle x, but I'm also getting that value not from a hard-coded number or a mathematical expression, but rather from the result of a function.
Here, since I think that's what my gut is telling me to do, let me go back a few points so I can write in my notes where we left off for note taking, which is about halfway through it, so I'm happy with that. You know, everything up until this point I feel like I understood very well, so I don't think I need to revisit all of this tomorrow, just the second half of the chapter. Maybe more like a third rather than half.
A function that we could begin a question, and I think
this is where we left off, so I'll say start a new note. I'll say left off at 1:55:18 in the video. Then we'll also add an arrow to that. Also italicize it. Here, if we're done taking notes, I'll also bold the title before I forget.
most wonderful.
This is the same size text. It is. For some reason, I feel so much bigger for some reason.
Function that we could begin to demonstrate this concept is the function random. Begin to set the background color of function calls. At the moment, every single function call that I've shown you just performs an action.
You know what? I'm actually going to say 155:00. I think that'll be more helpful to go back to as a point to go back to. Cool. But yeah, here. You know what? We still have 15 minutes left on stream, but I think it'll be helpful for me to start recapping now instead of later. So here. So is this the same distance from everything? I don't think so. There we go. No, Instagram stream didn't end in cam live after an hour today. However, the stream was no longer visible after an hour. Have I been writing that in my notes, copy and pasting that for a while now? Here, let me shorten that gap as well. Sorry, just making my notes a little bit more neat, to me at least. Yeah, have I been writing that every time? I have! So where did I first write that? Oh my god, I've been writing it so much, because that only happens one stream. Also, why is it ordered like that? There we go. Yeah, so it happened here. Yeah, let's go back and delete some of these. So this is 19th, 20th. Because I remember it only happened once. I've just been copying and pasting it without realizing. So 21st. Sorry, this is kind of boring to watch this part here, but very important for me to do just to keep organized with everything. 22nd. Then 23rd. Is that today? Yes. So we're back off to today. Cool. So yeah, let's start to recap. We're a little bit early to recap, but I'll say we worked on random numbers, on the random number. Actually, instead of worked on, I'll say we began, to clarify that we didn't finish it. So began the random numbers chapter and learn processing. And yeah, you know what? We didn't finish it. That's okay. I think it'll be good for me to revisit. So I'll say agenda, I'll say complete chapter random numbers and learn processing. We'll begin the next one on conditionals. Let me copy and paste that. Begin chapter conditionals. And he also has an assignment for us at the end of this random number chapter, so I'll say complete assignment for chapter, I'll say end of chapter assignment. For random numbers. And learn processing. Probably don't need to write the whole name of the tutorial over and over again, but hey, might as well. We've been copying and pasting it, so I'll just write it so it looks the same. Cool. And then make an agenda for next time, and then tomorrow is Thursday, so it's our last stream of the week. Haven't streamed a lot this week, but we've only really missed one if you don't count Sunday. So we kind of missed two, but mainly only one, so that's okay. So I'll say September 26th is tomorrow. And what else? I'll leave this here. Also say update website, especially the live streaming section, because that is very out of date. Here, I think I have it as a command still. Yeah, this command is very much out of date, or the website link is very much out of date, so I do gotta update that. I haven't updated it since I started streaming again, but hey, that's okay. Well, anything else? So I got 20 minutes left. We didn't even, we did watch the random numbers through once, but here I kind of want to take a quick look. Sorry, I was trying to find the website for this book. I kind of wanted to look briefly at the randomness chapter here, because just out of curiosity, and we'll add this to what we did today. So I'll say briefly looked at chapter 0 randomness and the nature of code by Daniel Schiffman. Quotes to the chapter 2. And I'll say, since it was relevant to today's topics. And I'll also here copy and paste this over, but instead of this link, we'll put in the link to this exact chapter. And this is what we'll end stream with doing, which is kind of out of order now. So let me actually make it in order. Instead of Sundays, I'll say for Thursday's stream. Actually, this should have been Wednesday too, not Sunday. I like that I get to copy and paste the formatting from stream to stream of how I keep everything organized, but it does cause some flaws like that, specifically when I forget to change days of the week. But yeah, here. So let's take a look here. So this is a random numbers table from 1 million random digits with 100,000 normal deviats. I hope I'm saying that correctly. I don't know why I'm saying that incorrectly, by the RAND Corporation. In 1947, the RAND Corporation produced a peculiar book called 1 Million Random Digits with 100,000 Normal Deviates. This book wasn't a work of literature or philosophical treatise on randomness. Rather, it was a table of random numbers generated using an electronic simulation of a roulette wheel. This book was one of the last in a series of random number tables produced from the mid-1920s to the 1950s. With the development of high-speed computers, it became faster to generate pseudo-random numbers than to read them from tables. And so this era of printed random number tables ultimately came to an end. That's pretty interesting. Excuse me, that's very interesting, the history of that. I like that I started the chapter off with that. So here we are at the beginning. Again, this is chapter 0 of this book. I'm interested why it's chapter 0 and not chapter 1 is where we start. If it's been a while since you've programmed in JavaScript or done any math for that matter, this chapter will reacquaint your mind with computational thinking. So we are not working in JavaScript or P5.js right now. We've been working in processing or what's it called? Here, I'll also put the link to this in the chat too. We've been working in processing, which is a port of, I believe a port is the right term for Java instead of JavaScript. So yeah, I wonder if we can go straight from what we're doing now into this book later on stream, or if we'll have to do some basic knowledge about P5.js and JavaScript first. But anyways, to start your coding of Nature Journey, I'll introduce you to some foundational tools for programming simulations, random numbers, random distributions, and noise. Be interested to learn about noise later in the in the tutorial we're currently working through. Think of this as the first 0th element of the array that makes up this book, a refresher and a gateway for the possibilities that lie ahead. There we go. That's why it's called chapter 0. So there's the answer to my question already. Here, I'm gonna adjust one more thing. Check. Yeah, just editing an audio thing real quick. Hopefully this sounds better on my end. Cool. But anyways, in chapter 1, I'm going to talk about the concept of a vector and how it will serve as the building block for simulating motion throughout this book. But before I take that step, let's think about what it means for something to move around a digital canvas. I'll begin with one of the best known and simplest simulations of motion, the random walk. And just another thing with the audio, there we go. Just so I can hear myself a little bit better. So imagine you're standing in the middle of a balance beam. Every 10 seconds you flip a coin. Here, take a step forward, tails take a step back. This is a random walk, a path defined as a series of random steps. Stepping carefully off that balance beam onto the floor, you could expand your random walk from one dimension moving only forward and back to 2 dimensions moving back, forward, back, left, and right. Now there are 4 possibilities. You'd have to flip the same coin twice to determine each next step. Cool. So I said this is related to what we were working on today, and it definitely is, but it's also absolutely different too. That's cool to see this example of a random walk rather than just producing random numbers in our code like we did earlier today. This may seem like an unsophisticated algorithm, but you can use random walks to model all sorts of phenomena that occur in the real world. That's interesting too, that what I was saying is it's good to use a, what's the word I was looking for? Sorry, adjusting the audio again. I was saying that just random functions in general simulate nature or phenomena in the real world, but I like that how instead of random generally, he's specifically referring to random walks for that. So that's very interesting. And I feel like, learning this now might be helpful when we move into Godot too, and try to simulate real world physics. Not that I'll be too concerned with simulating real world physics and the kinds of games I want to make, but it is interesting though. I think a random walk like this will be helpful. From the movements of molecules in a gas to the foraging of an animal to the behavior of a gambler spending a day at the casino, for our purposes, the random walk is the perfect place to start for 3 reasons. 1, I'd like to review a programming concept central to this book, object-oriented programming. Oh, so that'll be really helpful when we go into Godot too. I'm going to write this all down. The random walker I'm about to create will serve as a template for using object-oriented design to make things move around the computer graphics canvas. 2, the random walk instigates the 2 questions that I'll ask over and over again throughout this book. How do you define the rules that govern the behavior of objects? That's interesting. And then how do I implement these rules in code? Take a second look at that sentence. Definitely, if we're properly going through this, I'd be taking notes here. But anyways, I just want to quickly look at this just to get a sense of what it will cover. You'll periodically need a basic understanding of randomness, probability, and Perlin noise for this book's projects. The random walk will allow me to demonstrate key points that will become handy later. I'll review a bit of object-oriented programming, OOP, by coding a walker class to create walker objects. that can go for a random walk. This will be only a cursory review. If you've never worked with object-oriented programming before, you may want to something more comprehensive. I'd suggest stopping here and reviewing the objects section of my code programming with P5JS video course at the end of the Coding Train website. Cool. So I think at the end of my current project, we'll learn a little bit about this, but about object-oriented programming in the tutorial we're working through again, but reading about in JavaScript and very clearly here might be helpful. So I'll leave myself a note. Should definitely read this first chapter, chapter 0, before jumping into Godot, as it serves as a reference, a refresher, that's the word. Excuse me, a refresher for object-oriented programming. I'll say OOP in parentheses, so I remember that. Before Godot, I should also review this above tutorial on object-oriented, I'll say OOP, on OOP, as recommended in chapter 0 of this book. Cool. So I'm going to put a arrow to that here. And then another arrow to this tutorial. Cool. Well, that was helpful. I'm glad I did that. I do need to wrap up any second now. It's 6:30. I really need to stop right at 6:30, but really quick, just want to look. So we have the random walker class. I just want to look at, what's it called? The names of each section of this chapter. Oh, we can do that in the table of contents here. So chapters, chapter zeros. Didn't it say something if we hover over it? No? I swore I saw sub chapters too when we clicked on that. Maybe not. So random walks, the random walker class. Traditional random walk, random number distribution, probability and non-uniform distributions. Very engineering sounding, but again, this is all for the purpose of our design. Even in a book like this, just normal distribution of random numbers. Gaussian distribution. That's interesting. I've heard about the Gaussian blur. It's so interesting what Gaussian really means, especially in the context of this book and programming and such. Smoother approach with Perlin noise. So yeah, I'll be interested to learn what Perlin noise is as well. I have no idea. It's obviously related to randomness. Cool. Then ecosystem projects. So that's interesting. I wonder if we'll make our own ecosystem with code. Anyways, I was just curious. Thought I'd do that on stream since I was curious about it. And I'm glad I did, just because I think this will be really good to, even if we don't review the entire book, which I kind of want to, but at least review that first chapter before we jump into Godot. Because Godot's coding language, GD script, uses object-oriented programming, and they recommended having familiarity with that and other basic programming concepts before jumping into it, which is why we started doing this whole processing tutorial in the first place. But anyways, I need to wrap up at 6:30. I gotta get out of here. I gotta eat some dinner, then go on to another event later tonight. So yeah, let me see. Oh, sorry, just got a notification that I gotta end the Instagram stream, or it ended for me, but I should click end video. There we go. just at an hour now. So yeah, if you're watching, thank you so much for watching. If you're watching the VOD, I'm live Mondays through Thursdays at 5:30 p.m. Eastern time, 2:30 p.m. Pacific time for about an hour each day. Yeah, today was maybe a little bit more boring to watch than usual, but hopefully it was nice to have on in the background as you're working on your own projects. That's kind of the goal of these streams, is to have it as nice motivators for your own project. Something to keep on in the background as you're working on things, because I find that's really helpful and important for me to have when I'm working on things. Not always, but a lot of times it is. And yeah, and it's great documentation too. So in years from now, I can see everything I learned and worked on very clearly. Here, let me go to main cam for this part. It's nice having that documentation of the process of all my work. Maybe I'll even start painting on these streams. I think that would be great too, to again continue my documentation of my practice, even though painting's a little bit, for lack of a better word, more vulnerable for me to do on stream too, rather than working through tutorials. It might be a little less interesting to watch. It might be harder for me to talk about things as I'm working on them, but hey, maybe those are all good things and more the reason why I should do it, because I also feel weird about how secretive a lot of artists are about their process. I wish I had videos I could watch of every artist that I love and how they make and think about their work. So maybe I can contribute to that and start that myself. But anyways, thanks for watching. If you're watching the VOD, please follow, subscribe if you're on Twitch or YouTube. That way you know when I go live, you'll get a little notification for it. And thank you so much for watching. If you're watching on Twitch, stick around. We're about to raid someone. And yeah, hope you all have a great day. Thank you so much for stopping by. Bye.